The first page should have been you should have been pretty good at. The second page, I feel like one more or one half day extra would have been enough for you to grasp that one as well. Okay, so you must show formulas and calculator work if you want full marks. Okay, so in the United States, the average IQ is 100. So that's your average, right? That's my mean. Standard deviation is 15. What percentage of the population would you expect to have an IQ lower than 85? So I just want you to understand that I'm not asking you to graph a normal curve, right? Even though it is possible, right? So if this is 100, 1, 2, 3, I will do this because I want to illustrate. So if you want to do the same, go for it. This is your IQ, and we have 15, right? So it's 115, 130, 145 going this way, and then you have 85, 70, and 55, right? On either side. This is your average, so it's going this way. Yikes. There we go. So just to have a bit of an idea of what to expect. And notice that every single one of these values has a z-score associated with it. Always think of them going hand in hand. So it's 0, 1, 2, 3, negative 1, negative 2, negative 3. It's very helpful to think of it in those terms. Okay, so because you can bridge the gap there between the two. And so they're asking for percentage that has an IQ lower than 85. So if you go over here, less than 85, right? We could actually use our graph if we had graphed it to figure that out, but I don't want you to do that. I want you to use normal CDF. If I'm not asking you to graph, then you're using that. We're going to use a really small number, okay, as our lower limit, and 85 is going to be our upper limit, and our average is 100, and standard deviation 15. We're going to multiply that by 100, right? And so that gives us 0.1566, keeps going, times 100, which then would give us 15.86% likelihood of someone having an IQ less than 85. Okay? And we can kind of confirm that if you know your percentages. 85 is right about there, so right, it does make sense that it's in the 15% or so if you add them all up. And this is 0.15 here for the remainder, right? So what percentage, again, what percentage we need to use normal CDF for sure. What percentage of the population would you expect to have an IQ between 90 and 120? So they're giving you the upper and the lower limit. Okay, do you remember how to find normal CDF? Second vars, right? That's how you do it. And we get 0.6529 times 100, which is 65 point. My vision is 65. My vision is getting the best of me here. 65629. 65629, sorry. And that's 65.63%. And that's what you're after there. Okay. What IQ would have only 40%? So what IQ is actually asking for a specific data point. In this case, it's IQ. It could be length in centimeters, it could be time in hours, minutes, what have you. But it's what IQ would have only 40% scoring higher on the test. So here I want you to have this. You kind of need to know where you're located. Only 40% would be higher. Remember, this is where 50 is below, 50 is above. So if 40% is higher, you're looking at somewhere in here, right? This is the point along the x-axis that you're interested in. So that means that 60% score lower because they always add up to 100. So you have to use inverse norm, don't put in the 0.4, because then you're saying that this line is over here where 40% is below you, right? Let me just bring this up. Technically 60 are below. That's what inverse norm means. What is to the left of the data point you're interested in? And no times 100 here. Okay, so you take this. This is where that very catchy song by Beyonce comes in handy, right? To the left, right? Try to remember that. And you, well, it was catchy at some point. So there we go. What do we have? 103.8, right? IQ score. That's the score. It's not as a percent, it's just, that's your IQ, right? It just stays there. So that's what, so this would actually be worth 2 marks. Because, right, this part here and the fact that you use inverse norm, so 2 marks associated with that question, okay? Suppose that we are told that the heights of adult males in a particular region are normally distributed, right? We know, okay, it's going to be a bell curve if I were to graph this. The mean is 70, standard deviation is 2. What proportion? It's the same thing. What percentage? What is the likelihood of adult males being between 72 and 73 inches? So normal CDF, 72, 73, they actually give you both. So no million there, okay? And you have 70 and 2. This you have to multiply by 100. And you get what do I have here? Hold on. 0.0918. That keeps going times 100. And that is 9.18. Next, what height corresponds to the point where 20, so what height? They're asking for actual height, where 20% of adult males are greater than this height. Again, try to imagine, right? You want a point along the x-axis where 20% are basically taller, right? That would put you right about there, where 20% is here, 80% is there. This is the value that you're after, right? So if you want an actual value, not percentage, unless the value you're after is a test score, which could be as a percentage, right? You got to be careful. This is 0.8 and 72, like that. And so that's 71.68 inches. That's the height that would put you in that place where 20% of males would be taller. What height corresponds to the point where 20% of all adult males are less than this height? There we go. Do one of these. So the height where 20% are less. So that's actually here. And that's all you need. You only need that 20. Inverse norm. 0.2, 70, and 2. And that gives me 68.32 inches. Okay. So in this case, this is where, so it makes sense that, right, the height would be less than 70 because only 20% are less than that particular height. Okay. Let's keep going. I hope you're writing this now. So this one is tricky, and it can be done using the calculator. So I think today I will show you using the calculator. What is the height of a chocolate bar with a z-score of negative 2.7? So remember, a z-score of negative 2.7, are you to the left or to the right of the mean? Left. Almost like this is 1, 2, 3. This would be negative 3, negative 2, negative 1, 0, right? 1, 2, 3. Negative 2.7 is right about there. Right about there. So we need to now figure out the weight that would go with it, because we know that our average weight is 8 and our standard deviation is 0.1. So this is 7.9, 7.8, 7.7, but you don't know. There's a z-score that goes with this point that is not quite at negative 3. Okay, there's this. This is the score we're after. What's the weight there? So this is going to be my strategy. I'm going to go normal CDF, and I'm going to find the percentage that's to the left of that z-score, which is 2.7. So I'm going to go minus a million, 2.7, so lower and upper. What's my mean if it's z-scores? 0, right? In unison, I heard that one. So that's pretty good. And I will leave this as a decimal, folks. I get this. Watch, it's a very small number. 0.00347. I'm going to use 5 decimals just to be safe. So using the z-score, okay, using the negative 2.7, which is right here, I find the percentage of values that are to the left, right? Like the percentage of values to the left of that z-score. And now I'm going to go inverse norm. Inverse norm. And I will say, well, inverse norm, if 0.00347, right? If this is the percentage that's to the left of the value, and you just give it the mean and the standard deviation of the actual values here, because remember they correspond, I will get that value, which is 7.73 ounces. I will put an arrow there. Did anybody get this? Because anybody get this one? Did you get it? Yeah. Anybody else get this? Because this one was a tough cookie. This is a tough cookie. So this is a bonus. If you got this, this would have been a bonus. Okay. Okay. Chocolate bars less than 7.7. This one you should have been able to do. Less than 7.7 ounces are rejected and not sold in stores. If a factory produces 12,000 a day, how many of those are usable? Usable. Okay. So I will do this. Usable. I will do this. Normal CDF. Anything above that, so 7.75 to 1 million, okay? From 7.75 ounces all the way to the other end, which I'm just going to use 1 million. And this is my mean and standard deviation, right? That percentage is going to tell me how many are usable. So let's go ahead and figure that out. Griffin has my calculator. Can I borrow it for a bit? Because I did it slightly different. So here we go, second vars, 7.75, 1 million, and then 8.1, close that. So 0.993, and you can just go 8 if you want, 4 decimals. The reason I'm not going to write it as a percentage is because I'm going to use it to figure out how many are usable. So this is usable as a percentage, and then number of, we're talking chocolate bars, right? Number of usable bars would be 12,000 that are being produced times the likelihood that they will actually be usable. Okay, so you go 12,000 times 0.9938, and that's 11,925.6, which is approximately 11,000. What would you round that to be safe? I would keep it at 925, right? Because you don't want to quite say 926 because you don't have that full usable. So if you did 126, I would not mark it. I wouldn't sweat it there. So again, let me go back up to my graph here. 7.75 is somewhere way down here, right? So we're saying that everything to the right of it is acceptable, which we found to be 99.38%. So if you have 12,000 produced, then this many would be acceptable. So it's 11,925 bars that we could say are going to be usable. Okay. Now we are given this is a frequency table. Okay. Frequency table. You need to find the midpoints here. I don't know if you caught that, but you need to find the midpoint. So if you're having a hard time, just go 15 plus 19, enter, hit enter, okay? Don't divide right away because it's not going to be right. So 17 is your midpoint there, and you keep doing that, and I see a pattern after a while. So it's 22. It goes up by 5 essentially. 37, 42, 47, and so forth. Those are your midpoints, and that goes into L1, and this will go into L2. And then we go 1 var stats, L1, comma L2, and then we get our mean and our standard deviation out of that. So let's go ahead and type that in. You already did that. Oh, look, Griffin did this for me already. Perfect. Just checking. Yeah, thank you, Griffin. I'll hand them out more often. Okay, so we go stat, one variable stat, L1, L2, and there's your average, 31.99. And what are we talking about? We're talking about years, right? Almost 32. And our standard deviation is 5.82. By the way, this is frequency, right? Percentage is how often that is, how likely that is to happen. Okay, so this is your data, and this is your interval, right? And this is your frequency. Mothers who were under 18, percentage of mothers, right? So we go normal CDF, and we're looking at age, right? So we're going to go minus 1 million just to make sure, right? It's a bit silly, I know, but here we go, 18, and our average is 31.99. Our standard deviation is 5.82. and we're going to multiply that by 100. And there we go. We get 0.81% of mothers. Did this help going over it again? Yeah? I know it's complicated. Statistics, that's why, you know what? Most of you might have to take Stats 101 in university, and a lot of students drop out. Don't do that. Okay, it's just a little bit tough at the beginning, but if you practice, and you will have this advantage of having used technology and kind of analyze. You're not just doing mean median mode all the time, because that's what stats will be all about. Okay, so put this in your notes, keep it, and can you grab your notes and then we'll continue? Yep.